Hello students! Previously, we saw how a covalent bond is formed by carbon. Before going to various carbon compounds, let us have a look at some simple molecules formed by the sharing of valence electrons, that is, formed by covalent bond. We now know that when a single pair of electrons is shared between two atoms, the atoms form a single covalent bond. Can you guess the simplest atom that forms a single covalent bond? Yes, the hydrogen. It's true. The simplest molecule formed in this manner is that of hydrogen. As you know, the atomic number of hydrogen is 1. Hence, it has only one electron in its K shell. Now this is the K orbit of hydrogen, which is also its valence orbit. And this one electron is its valence electron. Now it can lose this electron and form a positive ion like nonmetals to become stable. But observe that after losing this electron, only a nucleus with a single proton will exist and no electrons will be there. But a single proton, on the other hand, cannot exist, and this creates instability and is thus not possible. Now, by gaining one electron like metals, it can also form negative ions. It will indeed complete its doublet and make it stable. But the problem is that many times there are only hydrogen atoms present all around. Or in some reactions, if no other atoms are present, they cannot donate electrons to hydrogen atom and form ionic bond with this hydrogen. So then, the option is to share valence electrons with each other in such cases. Thus here, two hydrogen atoms will share their 1,1 valence electron to form a molecule of hydrogen, that is H2. Symbolically, it is represented with a dash between two hydrogen atoms like this, H-H. This dash is a symbol of single covalent bond. Both these hydrogen atoms now attain the electronic configuration of the nearest noble gas helium. That is, they have two valence electrons and have completed their doublet, and thus have now become stable. So will it have an electron dot representation or a Lewis structure? Yes, obviously yes. To draw that, write two hydrogen atoms symbolically like this. Represent the valence electron as a dot for one hydrogen atom and cross for the other atom. As said, both of these atoms share their electrons, which is shown like this by circles. It shows that this shared pair of electrons belongs to both the atoms. So clearly, both of them have now two electrons and have completed their doublet to become stable. This pair of shared electrons forms a bond with two hydrogen atoms. And since only one pair of electrons is shared, the bond formed here is a single covalent bond. Now let's look at the bond formation in chlorine molecule, that is Cl2. What is the atomic number of chlorine? Correct, it's 17. So its electronic configuration will be 2, 8, 7. The first orbit K will have 2 electrons, second orbit L will have 8, and the outermost orbit or the valence orbit M will have 7 electrons. So from here it is clear that chlorine has 7 valence electrons and therefore it needs 1 electron to complete its octet and become stable. Now to do so, the easiest way to accept 1 electron from any other element. But just like in case of hydrogen, here also in cases when there are only chlorine atoms or there are no enough atoms to form ionic bonds with chlorine, by donating their electrons, the option is to share. and form a covalent bond. Thus, two chlorine atoms will covalently bind to form a chlorine molecule Cl2, symbolically written as Cl-Cl. Now what about its Lewis structure? Here it is. Observe that these are two chlorine atoms symbolically written. These are the 7 valence electrons. For one, we have shown electrons as dots and the other we have shown as crosses. And here is the shared pair of electrons shown by drawing circles. As you know, this pair of shared electrons now belongs to both chlorine atoms. So both chlorine atoms now have an octet configuration, that is 8 electrons in their valence shell. You can see 7 electrons of their own and 1 from the other atom. And this is a single covalent bond between chlorine atoms, thus forming chlorine molecule. Again, this dash represents single covalent bond. Now students, this is about single covalent bond formation. What about molecules with double and triple bonds? We will see them in our next video.